Hello everyone, in this video we'll be solving problem 3541. Find most frequent vowel and consonant. The problem statement is we are given a string S consisting of lowercase English letters A to Z. Our task is to find the vowel with the highest frequency and a consonant with the highest frequency, sum them together and return as the output. In example number 1, the given word is successes, and if we break it down into separate consonants and vowels, we have U whose frequency is 1 and E whose frequency is 2. Between the two vowels, the highest frequency is 2, and in consonants, we have the character S whose frequency is 4. Hence, the output is 6. The problem statement is easy and straightforward to understand and implement. Let's switch to whiteboard and discuss how we can solve it. Let's take the same example given to us in the problem statement. The simplest way to solve this problem is to iterate through all of the characters into given string and identify if it is a vowel or a consonant. Depending on the character being a vowel or a consonant, we'll record its corresponding frequency in separate collections. And once we have the frequency for all the vowels and consonants, we can identify the highest one between the two, sum them up and return the output. Let's do a quick dry run to get a better idea about this approach. In this string, we have two vowels. One is a U and other is an E. In the entire string, U occurs once while E occurs twice. And on the right hand side, we have two consonants, S and C. S occurs 4 times and C occurs twice. Between all vowels, the highest frequency character is E and the value is 2. While amongst all consonants, the highest frequency is S and the value is 4. Adding them together gives us the total of 6. As I had mentioned earlier, the problem statement is very easy and so is its solution. The time complexity of this solution is O of S, where S is the number of characters in the given string. This is because we need to iterate through the entire string at least once to identify the frequency of each of the characters before we can find out the highest frequency for vowels and consonants. While the space complexity is going to be O of 1, this is because the maximum size of these two collections is not going to go more than the number of alphabet itself, which is 26. As 26 is a constant, we can also say the space complexity is O of 1, that is constant space. I hope you are able to understand this explanation. Let me show you how we can implement this using Python. In this Python implementation, I've initialized a collection of type integer array, setting the length to 26. After that, I've initialized a collection with all of the vowels, which will be useful to do a lookup and verify if the corresponding character in the original input string is a string or vowel or not. Next step is to run a for loop and identify or calculate the frequency of all of the characters in the input string. On the next line, I've initialized two variables to record the maximum vowel frequency and consonant frequency, setting the default value to 0. Next step is to identify the maximum frequency for a vowel and a consonant. Next for loop will help out with that calculation. In this loop, I am iterating through all of the characters and checking if the corresponding character is a vowel. If yes, then I'm taking its frequency and comparing it against max vowel frequency. And between the two, the higher value will be saved back into the max vowel frequency. If the character is not a vowel, which means it is a consonant, so I'm comparing its frequency with the max consonant frequency variable, and the higher value will be saved into the max consonant frequency variable. Once the for loop is complete, I am summing the max vowel and max concurrent frequency and returning it as the output. This code, when submitted on LeetCode, beats 65% of the submissions in terms of runtime and nearly 87% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.